Welcome to our lesson on dividing radical expressions. Recall that when a fraction is multiplied by 1, its value doesn't change. So the number doesn't necessarily need to be 1. It just needs to be some sort of fraction that has the same number in the numerator and the denominator. So for example, 2 over 2 is the same thing as saying 1. 5 over 5 is the same thing as saying 1. So for example, if I'm trying to find another way to express a half, what I can do is multiply by a 1 or a number that is the same top and bottom, like 6 over 6. And this will give us something that is equivalent to 1 over 2. So for example, 6 over 12 is the same thing as saying a half. So we're going to use the same sort of strategy when we're dividing radical expressions. So for example, 1 over the root of 2 is not in a simplified form because we can't have a radical in the denominator. So that means we're going to get rid of the radical in the denominator, which is called rationalizing the denominator. So whenever we're getting rid of the radical in the denominator, we're actually rationalizing the denominator. And in order to do this, we're going to multiply the top and bottom by the radical in that denominator. So for example, if we have 1 over the root of 2, I'm going to multiply top and bottom by root 2. So I can get rid of that root 2 on the bottom. And then when we multiply, we're going to multiply across. So that's a 1 times root 2 in the numerator. And then root 2 times root 2 in the denominator is just 2. So that means 1 over root 2 is the same thing as saying root 2 over 2. Here is not simplified. This is simplified and rationalized. So in our first example, we're going to do various examples of different ways of rationalizing. So for part A, because we have root 7 on the bottom, we're going to multiply top and bottom by root 7. Then in the numerator, I'm going to have to multiply root 7 with this term and the second term. So our coefficient is 5 for that first term. Root 7 times root 7 is just 7. And then root 7 times 3 is 3 root 7. In our denominator, root 7 times root 7 is 7. We can simplify this just a bit. And then that would be our simplified form. And we know it's simplified because we don't have a rational, we don't have a square root or radical in the bottom. Moving on to B, we're going to multiply top and bottom by root 3 because that is what we have in the denominator. We don't need to multiply by 2 because that is not the problem. Our coefficient is not the problem, it's the root 3 that's the problem. Okay, so I'm going to multiply this root 3 with the 2 root 3 and also the 1. So that gives us 2 times 3 because root 3 times root 3 is 3. And then 1 times root 3 is root 3. In our denominator, you're going to have a coefficient of 2 still because that's 2 times 1. But root 3 times root 3 is 3. Now we're going to simplify this a bit. And then that would be our simplified form. Moving on to C. Instead of multiplying top and bottom by 18, root 18, I could just simplify this first, just so we can deal with smaller numbers, because I can rewrite the root of 18 as the root of 9 times 2. And then I know what the square root of 9 is. And it's 3. So then we're just left with root 2. Now I'm going to rationalize the denominator by multiplying top and bottom by root 2. So we got 6 times 2, 4 times, and then remember it'd be root 2 times root 3, which is root 6. In our denominator, that's 3. Root 2 times root 2 is 2. and then just simplify it. So we got 12 minus 4 root 6 over 6. If you take a look at our coefficients, we can divide each term by 2. So 12 divided by 2 is 6, 4 divided by 2 is 2, and 6 divided by 2 is 3. And then this is our most simplified form. If you would like to start by doing root 18 over root 18 and multiplying that, that's fine. You are going to deal with some bigger numbers. That's okay as well. You still need to get to this form here though, so you do need to simplify it to the very, very end. It's a little hard to do when you have larger numbers. So what happens when the denominator is a binomial? We want the radicals in the denominator to disappear still. So to do this, we multiply the denominator by binomial, so the product is a difference of squares. The binomial is called the conjugates. So for example, the conjugate of a plus b is a minus b. Conjugate of 5 plus root 2 is 5 minus root 2. So the conjugate of 2 minus root 6 would be 2 plus root 6. The conjugate of root 2 plus 3 would be root 2 minus 3. So all we really do is to change the sign in the middle to find the conjugate. So let's do our next two examples here. So to find the conjugate of this one, I'm just going to take the denominator, write exactly what we see, but change that sign to a plus 4 instead. And we're going to do that top and bottom. So then when we multiply, we are going to have to multiply to all terms, like so, 4 times, like we usually would do when we have two binomials. So the first one we have 4 times 3 root 2, which is 12 root 2. Then we have 4 times 4, which is 16. We have 2 root 6 times 3 root 2. So 2 times 3 is 6. Root 6 times root 2 is root 12. And then last we have 2 root 6 times 4, which is 8 root 6. In our denominator, we have 3 root 2 times 3 root 2, which is 9 times 2. So 3 times 3 gives us 9. Root 2 times root 2 gives us 2. Then we're going to do it for our next one. 3 root 2 times negative 4 is 12 root 2. Then moving on to our next term, which is 4. 4 times 3 root 2. 4 times 3 is 12. So left that root 2. And then lastly, 4 times negative 4 is negative 16. Now we're going to simplify this. We can see that these two terms cancel out in our denominator. And then in our numerator, nothing changes. There's nothing we can really simplify here. Unless you want to change the root to 12, we could do that. We could change it to 4 times 3. And then denominator, we have 9 times 2, which is 18, and then 18 minus 16. So for this term here, if I take out the root 4, that'd be 2, which is 6 times 2, and that's 12. Root 3 left over. No like terms there, but then we have a 2 in our denominator. Moving on to B, we're going to find the conjugate in our denominator. So that would be changing this plus to a negative. So that's 3 root 2 minus 2 root 3. I'm going to do the same top and bottom. All right, so we're going to do 2 times root 3 times 3 root 2 first, and then we'll do the other ones after. Okay, so 2 root 3 times 3 root 2, that is 6 root 6, because our coefficient is 2 times 3, and then our radicand is 3 times 2. For our next term, we have 2 root 3 times negative 2 root 3, which is negative 4 times 3. We have the 2 times 2 as our coefficient, and root 3 times root 3 is 3. Okay, now moving on to this term. We have negative 4 root 6 times 3 root 2, which is negative 12 from the 4 times 3, and the 6 times 2 is also 12. And the last term, negative 4 root 6 times negative 2 root 3, that'll be positive. Our coefficient is 4 times 2, which is 8. Root 6 times root 3 is root 18. And then in our denominator, we have 3 root 2 times 3 root 2. 3 times 3 is 9. Root 2 times root 2 is 2. Then we have 3 times 2 is 6. Root 2 times root 3 is root 6. Then we have this one to do. 2 root 3 times 3 root 2 is plus 6 root 6. And then our last term, we have 2 times 2, which is 4, and then root 3 times root 3 is 3. So we can simplify our numerator a little bit, and we're going to write this into more simplified mixed radicals. So I'm going to write the root 12 as 3 times 4, and the root 18 as 9 times 2. In our denominator, these two are gone. So then we have 9 times 2, which is 18, and then 4 times 3, which is 12. So here we can take out this root 4. The root of 4 is 2. So we have 12 times 2, which is 24 then, and left with root 3. For this one, we have root 9 to take out. So the root of 9 is 3. 8 times 3 is 24, and then we're left with root 2. 18 minus 12. Last thing we're going to do is simplify coefficients, because you have 6, 12, 24, 24, and 6. That means I can actually divide everything by 6. And we're just, again, looking at the coefficients only. So 6 divided by 6 is just 1. 12 divided by 6 is 2. 24 divided by 6 is 4. And lastly, 24 divided by 6 again is 4.